Hello, and thank you for joining me today as we discuss mechanical energy. So we've talked about kinetic and potential. Now we're going to talk mechanical and kind of just expand our understanding of energy as a whole. And so, for starters, mechanical energy is the sum of your kinetic and potential energies. That's going to be really important. For example, an apple falling from a tree has both kinetic and potential because it's falling, so it's above the ground, and it's moving because it's falling, so it's got kinetic as well. So the sum of your kinetic and potential is your mechanical energy. An apple can give you energy when you eat it, but where does it come from? So in all of this, we have different forms of energy that are related to the arrangement of atoms. We have these different forms of energy. At the atomic level, we call these non-mechanical because they're things we can't see and use. But they are really just various special forms of either kinetic or potential energy. And we're going to talk about that here. So when you have a chemical reaction take place, when we talk chemical reactions, we're talking about energy being released in the form of chemical energy. So energy stored between bonds. So these bonds are broken and that releases energy, or they're formed and they release energy. And so if you release this energy, you are decreasing your potential energy in the substance. For example, you strike a match and you get this flame and you release heat and light. Afterwards, so we released all of this stored energy to produce light and a little bit of hot gas. When we're done with that, that energy is now gone. And so we've lost our potential energy because it was used up producing that light and heat that we saw when the match was lit. Other forms of energy. So all living things get energy from the sun. That plants use this sunlight to produce their own chemical energy through photosynthesis. So photo means light, synthesis is the combining of things, and so they literally produce their food from light. So this chemical energy is stored in sugars, and then when something eats these plants or algae, we break down that energy inside of them, and we get our energy from them. So even though we don't directly get our energy from the sun, we get all of our energy in some way, shape, or form from the sun. So every bit of energy you've ever had came from the sun at one point in time. So the plants used it, converted it to something that we can use. We ate plants, and we got our energy. So where does the sun get its energy from? In this case, the sun gets its energy from nuclear reactions. So nuclear fusion is taking place in which you have two hydrogen atoms being slammed together to form helium. So along with giving energy to all living things, it also warms and brightens our planet. That takes energy as well. So energy that reaches the Earth from the sun is just a small portion of the sun's total solar output. And so again, that comes from nuclear fusion, and then we see and use it in a couple different ways. We can also talk about field energy. So energy can be stored in fields. For example, lights and appliances are powered by electrical energy. This energy is a result of charged particles in an electric field. So very similar to gravity, but these are charged particles that are in different locations within an electric field. When electrons move from areas of high to low electric potential, they gain energy and create magnetic fields as well. So we can produce a magnetic field with an electrical field. And so this moving electrons, these are what cause lightning. So lightning is actually the transfer of electrons and the movement of energy through those electrons there. And our last little bit of example. So on a bright summer day, is it hotter in direct sunlight on the sand or under the shade of an umbrella? Well, most people would say when I'm standing on the sand, it's a lot warmer, which is true. So the direct sunlight on the sand makes it much warmer. That is because light carries energy. And so the light that hits Earth from the sun across empty space actually carries energy with it. So some of that fusion that the sun is doing is being transferred into light, which then creates heat. And those travel in the form of electromagnetic waves, which we'll talk about here shortly in next couple units. But that is our discussion on mechanical energy. So I would like you to answer question 1, answer question 2, answer question 3. And then I would like you to answer questions 7, 8, and 9, just to do some practice on math. But thank you very much for joining me today, and I look forward to working with you as we continue discussing energy.